We'll start with just some admin. This is a relatively small room. We've had a couple hundred people in here. So if you are going to ask a question later, can you just try to use the mic or project, because people at the back can't hear as well. And I think that's it. There's no one standing. We have to, because the fire marshal, if this room's full, we have to get everyone to sit down or leave the room. So it doesn't look like there's going to be a problem at the moment. Anyway, introduce myself quickly. I'm Carrie Sinclair. My dad, Ken Sinclair, is the founder of Automated Buildings. This is our 26th year of providing free education sessions for the industry at AHR. They are a great partner of ours, as well as Cochrane, who helps us put these together. And the team here, I'm very thankful for. They haven't been thanked by any of the panels, so I'm going to give these guys thank you for all the stuff you're doing. I've got a great panel today, and we're going to talk about scaling your business with cloud. Obviously, if I introduce everyone, that will take a long time. So what I'm going to do is start by having them introduce themselves, and I'm going to pose a question at the same time, and they can introduce themselves and then provide you some more context about what they do through the answer to the question. We have two Stevens. So Stephen Dawson Haggerty is in the middle there, next between Rick and Corey, and Stephen Holicky has said that I'm allowed to call him Holicky. So if you hear me address a question to Holicky, that is the second Stephen. So I might start with Rick, since you're sitting next to me. Can you tell us how you got involved with the Coalition for Smarter Buildings? As we saw in the Smarter Summit on Sunday, you're working hard on open standards and best practices for interoperable smarter buildings. And you've recently advocated the Linux Foundation. So just help us understand in the context of scaling in the cloud. So your background, how you got there, and what is this when you think about scaling?
So how did we start this Coalition for Smarter Buildings? Whose idea was it? It was somebody that's in this room, I'm sure. But the whole idea was 3 or 4 years ago, coming together as an industry, just identify what the problems are with why don't we have smarter buildings? Why don't we have more smarter buildings? And so we formed a 501c3 to say, hey, if we get the best and brightest people to attend these meetings, to first identify and then start to form groups to be able to go solve, perhaps we can, advance the pace of smarter building adoption. And over 4 or 5 years, we've done quite a bit of work on creating standards like 2525. Got the IBB that we've announced, and just as an opportunity to say, hey, if we come together as a community, things can actually get better faster. A year ago, at this show, we were approached by some members of the Linux Foundation and started having conversations about, wow, we could adopt some of the Linux approaches to community building and problem solving and technology development. And then, a few months ago, they said, hey, we'd like to acquire C4SB and have C4SB be the entity that leads the charge in Linux for buildings. I'm not supposed to say Linux for buildings, but I will say it 20 times probably between now and the end of the day. But Linux is coming to buildings, and as of this morning, the press release came out that said that this formation is happening where the coalition is being brought in. Now, the Linux Foundation has a very specific view of, or not, I shouldn't say very specific, but they have an actual definition of what cloud is, and so we'll talk about that as we go here. And a lot of people think of Linux Foundation as mostly just a kernel, but there's 1,000 other projects that the Linux Foundation brings people together to work on code and work on standards, and so we'll talk about some of those as we go through here. But the impact on most industries, or every industry that the Linux Foundation has joined, has been that the industry moves faster, that people's careers advance faster, code advance faster, and companies that take advantage of open source seem to end up at the top of every industry's rankings. So we're excited about the fact that the Linux Foundation has said, yeah, let's take the lead and blast on into the building space.
Great. At Automated Buildings, we really thrive on a diverse panel and conversation. So we'll might move to Stephen. When you founded Normal, you set a big mission to make every building a connected building. So give us some background on how you ended up doing that, I guess, and explain why this is so important for this conversation.
Yeah, I think buildings are kind of an interesting technological place because I sort of compare the historical sort of DDC stuff to being a little bit more like mainframe programming. And, as that sort of transitions to the cloud, a lot of things are going to change, right? Because I think the cloud means a lot of things to a lot of people, but usually when you manage data centers, right, they're highly automated, they're highly orchestrated, they're highly consistent, and that's how you achieve, security, reliability, uptime, all of those abilities that people like, I think, in buildings. And, relative to your sort of, and I think the mainframe analogy kind of hangs together because, maybe 20 years ago, and maybe even today, you have a guy in the basement banging out COBOL for mainframes. Doesn't look that different from line code, frankly. And programming these buildings as a one-off, and, that man or woman is really the only one who can then maintain that asset. On the other end, so you end up with 3 million commercial buildings with not very consistent computer infrastructures. Now a lot of the new stuff people hear about, everybody's excited about ChatGPT and all this other stuff, right? How is that going to ever get into buildings if you have this complete hodgepodge of IT infrastructures and programs and I think the problems that Brick and Haystack and 223P are solving are great, but really only scratching the surface because the real issue is how do you develop new businesses and value propositions on top of these fleets of buildings, not just single buildings. The single buildings work fine, frankly. And so, and obviously the connectivity is an important piece of that, although it's not the end piece there. And ultimately, I think what will create a lot of value for the ecosystem, make better buildings, make people happier, all that stuff is going to be improved scalability of software applications and applications running across fleets of buildings. And the way that you enable that is, it's a roadmap, right? But you containerize, connect, impose consistency, and have a more consistent ability to achieve scalability, right? And so that software businesses can actually scale reasonably without every new project being like a horrible integration nightmare, like they certainly have been over the past few years.
I'm going to talk about that a bit more. Corey, one of Neve's core products is an edge device. So another part of this conversation. Can you introduce yourself and explain why edge solutions are relevant into a discussion about scaling in the cloud?
Sure. So I'm Corey. I'm Chief Product Officer at Neve. We provide digital infrastructure for buildings. Our core product is a thing called Secure Edge. It does cybersecurity, remote access, cloud connectivity, and also edge application runtime environment. So you can run containerized apps like normal, Tritium on our device. The reason I'm here, so the short version is, we all work in buildings, and buildings are at the edge. So you need some connection there. So the edge is really important. They can't just have it in the cloud because there's not a lot of buildings in the cloud. The long version is that, I think cloud, people talk about it like it's a place, like put it in the cloud. And the cloud is, once you say it's a location, then you kind of have this weird dialectic where it's like either in the cloud or on-prem. And I think cloud isn't really a place. It's a design philosophy. You really need to think about service-based architecture, containerization, how you can run applications seamlessly between cloud and edge. You need to think about a software-defined WAN and a perimeter because the edge of the cloud doesn't really exist. The cloud can be at the edge. You can run a cluster of devices there. The edge could be in the cloud. You can use SD-WAN and pull all your devices up to the cloud. It's really thinking about how you design that so that you have that kind of optimal use of cloud kind of benefits, the flexibility, resiliency, centralized access, and how you can leverage the edge as part of that. So I think you can't really talk about edge or cloud. You kind of need to talk about it as a full architecture.
Great. And Holokey, Tritium is best known for its Niagara frameworks, which has obviously been a platform supporting this industry for decades, but it's not the cloud. It connects with the cloud. So can you tell us a bit yourself and help the audience understand if and why they need both?
Sure. My name is Stephen Holokey. I'm the Chief Product Officer for Tritium. I've been working in the smart buildings industry for about my entire career. Joined Tritium about 6 years ago. Prior to that, I was a system integrator working for an architectural and engineering firm out of Chicago, Illinois. So been kind of living and breathing this world for many years. So interesting comments here. So you said it's not in the cloud, but it connects with the cloud. And I think Corey really highlighted it. It's like, where is it running currently? So traditionally, you can run Niagara in a VM, and today you can run it in a container. And more often than not, we have many end customers that are actually, they're running it in the cloud. But the thing is that I think when we talk about whether it's in the cloud, Carrie, I think there's probably this notion that it has to be maybe a hosted solution, whereby, as Corey indicated, you have your software that's running within a container that can take advantage of some of the horizontal scalability you get on some of the platforms that's hosting it, and then augmenting what it does through the use of microservices that might be storing your historical trend records, your alarm records, and then providing the capabilities to remotely access that device and provide remote software updates. Those things are kind of part of what is otherwise our vision. And we have enabled this use case effectively through our channel partners. People can do this today, and they have been for some time. Now, of course, it does connect with the cloud as well, because for, I'd say, many examples, we have Niagara's running on-prem. And so there's actually JACEs, or there might be a supervisor on site, or the supervisor might be located in another location. But we do provide that connectivity with the cloud. Perhaps if you want to integrate with some external application that's seeking to do data analytics, perhaps you've got your own custom UI, you want to pull some of that information into an ERP, work order management system that are all running natively in the cloud. We provide those capabilities just to be able to fulfill that use case. But then also, again, if a customer wants to do it, and let's face it, many of the enterprise level customers, they have invested a significant amount of resources into their infrastructure. And what they have said, at least, is that, well, they want to manage the runtime. They want to manage exactly how it operates, the security updates, and things like that, even some of the remote access. So it's kind of nuanced, Carrie, because there's been many partners that have otherwise pushed Niagara to the cloud and continue to enjoy the benefits that you achieve through running your applications in the cloud. But of course, it provides that same connectivity with any of the on-premise components or the JACEs or any of the other connected devices kind of in a seamless fashion as well. So, I think I don't want to say this is up for interpretation, but there's a lot of nuance there. And I think Corey really touched on it, which I appreciate. It's more than just where is it running. It's the whole collection of all the services, applications that are interacting with this entire system.
So we talked about it in the previous panel around fear and how it might be stopping the industry. If you ask Google or look at Google Trends on, what people are asking Google in this industry, is the one that comes up, if you believe it or not, is, can we still run local automation if the internet goes down? Advice, I guess is my question to the panel is, so the fear, I think, of the cloud, or is that the internet goes, that seems to be the number one question. No one's maybe asked this in this room, but that's what everyone else is asking according to Google. So let's address it at the beginning and say, are you really running a full cloud solution, or are you actually running a hybrid solution where the building is still, you can talk to the building, but the cloud is just another, augmentation to it. And so I don't know who wants to, I'm happy to pick somebody, but I think you're all nodding, so I'm sure everyone's happy to talk about this.
I'll jump in. So I think that the fear is more on account of the cost. And I think that's one thing that at least we've realized, is that the hosting costs from some of these cloud providers, it's pretty exorbitant. And it feels like in order for us to have a truly cloud product, we have to use one of the big vendors. Like if it's not in AWS, it's not in Google, or it's not in Azure, it's not really cloud. And I'm kind of concerned because this is otherwise one, we'll call it domain, where they really haven't been able to penetrate. They haven't been able to really gain the coalescence around the industry to ensure that all of the data that gets created by buildings resides in the cloud. The financial industry has certainly nailed that down, and they've done a great job at normalizing their data structures and then pushing to the cloud so that they can use it, resell it, and do a myriad of other things. But I think with the BMS industry, this is something that's like an untapped potential for the cloud. And so some of this, I feel like we're being forced down a certain route. And the thing is that for building owners, specifically if you let's call it a small business owner, some of the hosting costs for cloud can get a bit exorbitant. And so I think there's some general reticence or concern as to whether I can actually sustain the required investment into the cloud to be able to support it. Now, one thing that we believe in is the whole notion of distributed control. Within every building, you should have at least some control node within your network architecture that can maintain operation of the building when you don't have a solid connection with the cloud. And so what that means is that any of those, call them global sequences that are going to be affecting all the airside, waterside systems, you have to have the ability to be able to execute those within the building. Now, of course, the cloud can take over as soon as that you've essentially restored that control. But the idea is real, is that, if I lose my network connectivity, I do not want my building to stop operating. And when we have a world in which everything is just IP devices going up to the cloud, it's much more difficult to ensure that the building's going to continue to operate per sequence, because you're going to have to do a lot of Fusion BACnet. Of course, you can achieve that to a certain respect, but when you have a distributed control node, such as a Jace, for example, in your building, you can ensure that there is still going to be some semblance of supervisory control in place. In addition to that, you can still ensure that you're collecting your trend records, your alarm records. And so when that internet connection is restored, push them back out to the cloud, push them to a relational database. It really safeguards the operation of the building and, of course, the investment they put into this product just to really move it forward. And so, Carrie, I think there's fear on account of the cost, fear because it's unknown, where an industry would like to do the same things over and over again. But I think there are some safeguards you can put in place to ensure the continuity of operations.
Great.
I also like to add, I think part of it's also like risk acclimatization, where people are used to the risks they currently have, which is my BMS is running on a PC in the basement, and that also could die. But they're used to that.
Yeah.
They're worried about the internet going out. But if you get redundant internet, solves that problem, and you move it to the cloud's not going to die. Like, that's the way you design the cloud. You have an application running across multiple servers, it's containerized, it's running as microservices. So I think people are used to the risk that they know, so they're focused on the risk they don't know, which is that internet going down.
I think it also actually points at a bit of a deeper architectural, issue with BMSs, is in that, I think when people tend to think about what it means to move the BMS to the cloud, I don't want to throw anybody under the bus, but I think they literally think like they're going to unplug that Dell PC under the facility manager's desk and like carry it into a data center, and now it's over there, which you can do. That's kind of the lift and shift version of cloud migration. But, I don't think it's a appropriate sort of refactoring of the architecture to account for that exact issue. And it is actually a serious issue. In other domains where they've gone through this transition, one of my analogy I like to make is in software-defined networking, where you can buy software-defined networking switches from Meraki or whatever, and the way that those work, they sort of have this same problem, right? Like, nobody wants their building internet to go down because their, management server is dead. And so you essentially have, and so the way they work, right, is like you have a management layer in the cloud, kind of like SCADA, and it just downloads everything into the building. And the difference there, I think, is that you're not manually, programming those switches at the building level, right? Like, you have a global policy, like, okay, you can't visit Facebook at work. That's automatically provisioned into the switches. And if the management layer goes down, you can't edit that. But, like, that's okay, right? Like, you can still visit YouTube and whatnot on those switches. And I think a similar sort of orchestration layer for buildings is really quite realistic, so that you can, in fact, guarantee that that local control persists and has, well-defined failure modes across, the fault domains, with the most obvious fault domain being like you cut the cable to the building. But there's more subtle ones, right? Like on a campus plant, right? Like, designers have to account for like, we're getting district steam, if the steam plant's down or we lose communication, like what happens there. And so I do think that the control system architecture is not quite embraced this, additional tier essentially in like an explicit way, basically. Whereas, and it is to the large extent still sort of living in this lift and shift world, which you can certainly engineer around, but requires extra attention that it shouldn't really require.
Hi, Charn. So, fear of the cloud. So Corey talked about the fact that the cloud can be defined as, or can be sort of redefined. And so if the cloud's actually in a server that's in your basement, are you really afraid of it now? Are you afraid of the cost? New architectures also allow for a kind of a different cost model as well. So one of the key things that we're trying to advocate for, what has been talked about, is that a new architecture for how software works, which is part of the definition of where is the cloud now? Where'd it go? Is it in my car? Is it in my basement? Or is it up in a server on AWS? And what we're wanting to bring attention to is that these new architectures, in some ways, had to be, you had to invent your own way to make the architecture work, but you knew that the right way to do it was to model after some of the other industries and use more IT tools. We want to make sure that as the Linux Foundation, we've been providing guidance for how to do that for other industries for decades, finally catching on. And we're going to have that ability to kind of bring together the experts to say, hey, how should we make that work for buildings? We already are advocating for what you heard us talk about, the IBB, which is an example of a device, it's a real device that starts to redefine where is the cloud and where's the edge. But the cost, I don't disagree with what Stephen said about the cost having been an issue, because holy cow, small business owners would get a tab at the end of the, it's like the bar tab from Sunday night. It's like, what's it going to look like? Never knew. But the new architectures allow for rethinking how you're distributing that and how you're planning that. I think that's what they tell me.
I mean, I think that's been a useful discussion, but I think sometimes what changes people away from the fear is the opportunity, so the positive side of the outcome that they can get by embracing scaling to the cloud. So if you took a hypothesis that said cloud-based BaaS transforms building automation from being reactive to being proactive, right? So what you're actually doing is instead of reacting to a building because it's having a problem, you're actually aiming to be more proactive to get on top of that problem. There are some real life examples that you can share in your experiences where you're actually helping the audience understand the value that you will be able to extract at a real level, like a practical level from doing this, that would kind of overcome because if I can see the benefit of doing something, I become less fearful of the cost, for example, because I can then do a cost-benefit analysis and I can say, hey, that's actually worth doing it. I'm not so scared of it, right? So let's just sort of stop there and try to think of some interesting stories that you guys have that you can kind of share with how this works and why you would consider doing this then, or how you consider doing it.
Can I start with that one?
Yeah, sure. Just go up and then back.
Real examples of new kinds of decisions. So the predictive maintenance one is a great one. And it's been really hard to get the different systems, the different digital systems that could help you make better decisions proactively instead of reactively. It's just been hard to get that integration to happen. We've all done it. Used to be fun, I thought. But it was really hard to get the sort of integrations to happen to be able to do predictive maintenance or even to do maintenance that was suggested by the manufacturer. But to be able to now have this integration pathway for a kind of a new type of integration, we're redefining how that happens. It's not just old, standard APIs anymore that were, again, fun and exciting, but it's new, a different approach to that integration. So the ability to have maintenance management system and a capital planning system and all the different other factors that can be influencing the predictive maintenance is now actually easier to do. So, and we can show how that happens, and we can show how it happens across multiple different systems. So you can have your financial systems and your maintenance systems and your building automation systems all be communicating in a consistent way, and now we can make decisions that are informed by all those different systems. And we're doing examples of it as we speak and presenting it. So,
thanks, Rick. Stephen?
One example that comes to mind is maybe even in a more traditional sort of base building control space. We're at AHR, right? There's been a lot of interest, I think, in these Guideline 36 sequences, and we've done some work deploying, which is essentially AHR's high performing sequence for HVAC operation. And we've done some work with some of our partners deploying these in various buildings. And what you find actually is that these sequences are great, but they're also a bit brittle in the sense, like, for instance, on the air side optimization, they read a lot more data out of the zones. They sort of have like a voting algorithm that they use to do air side resets. And as a result, if, on one hand, it's great, they are certainly way more efficient. On the other hand, if you just kind of like program them in and then leave them for 30 years, they're going to break after 6 months, and then you won't get those efficiency gains. And so it also requires more of this sort of like data ops, DevOps approach to these sequences at some level, where you're monitoring them, detecting outages, resolving them, some automatically, some manually, right? Like you get a stuck damper because you get too many stuck dampers, now you have too many rogue zones, and the thing just like cranks up the air handler static pressure, and it just sits there, right? And so, how do you, and so in a traditional BAS environment, you have an operator, and of course you could create an alarm on this in the BAS, but it really doesn't work, I think, unless you sort of operationalize that monitoring process around your control sequences so that you can detect, respond, and remediate, within a reasonable amount of time, and so that you keep the building performing. And, it is quite similar, I suppose, to the monitor-based, continuous commissioning efforts, but I think implementing those on, on-prem systems and then tying them together, I mean, come on, if people haven't done it yet, like, they're not going to do it. And it is substantially easier to do from the cloud, where you can just, text people or have an app or like, a bunch of notifications and, contextualize with the equipment information. And so I think that is, quite specific, but that's the kind of thing it really takes to get high-performing buildings. You have to implement that kind of process, and it's just substantially easier to do that, as a cloud application.
Right. Corey?
Sure. So one place we've seen a lot of ROI, and it's almost like a baby step to the cloud. Instead of, taking the big lift of moving applications, your BMS and access control to the cloud, it's just providing essentially cloud connectivity to the building for remote access. So, we've seen customers roll out just remote access, so you get that central visibility into all of the buildings, but from a single place, you don't have to go on site. And we've seen like a 75% reduction in truck rolls. So there's a real operational savings, because a lot of the alerts and alarms, you don't have to get in a truck, go get your laptop out, jack it in, figure out what's going on. You just log into a website and see what's happening. The other is like cloud management of the applications on premise. And we've seen, again, like a 70% acceleration in deployment. So it's easier to deploy from the cloud if you can go to a browser and deploy Tritium, any application, instead of having to, again, go on site and deal with that installation, all the commissioning. So like that's, like I said, it's a baby step. It's not the full move to the cloud, but it's at least a pretty high value ROI.
Great. Okay.
Yeah. So I think there's a couple real use cases. If anybody attended Realcomm last year, the GSA administrator came on stage with the keynote and kind of shared some of the good news about what they're doing. Now the GSA, which is the General Services Administration within the federal government, responsible for all the millions and millions of square feet across the country, they have been investing in, of course, normalizing, aggregating data through Niagara. Now, they've been pushing it to a cloud that they manage. And the reason why, it's for good reason, they do not want to open that up. And so security is another one of those things that traditionally serves as an impediment to the otherwise kind of full-scale adoption of the cloud. And that's kind of why I was saying that, enterprise customers will seek to kind of emulate what you would see in the cloud, except it's something that's either in a private cloud or within an environment that they manage. And so the federal government's been doing that for well over a decade. And so now they have just a massive amount of data from all their buildings across the U.S. And they're, of course, using a number of third-party applications to perform analytics across that data set. And one thing that the GSA administrator mentioned is just the real energy savings that they've been able to achieve just by using analytics across that data set. But we have to remember that gives us the chance to perhaps get into a much more, what I would say, proactive footing, because analytics are just going to be able to provide that capability. But there's still some limitations, and that's going to be with the site operators. It's kind of it's a journey that we kind of have to take together. And so even though we're getting the insights down to the site level, which you would hope would kind of change the behavior of the local O&M operators within the facility, we have to do more behind that. But I think the GSA at least has been able to demonstrate year-over-year energy savings, which of course, if you're a taxpayer, you should appreciate. And that's also a relevant use case of if you are an enterprise owner, or if you got a portfolio of buildings, you can achieve those same outcomes. And again, it's all about having the normalized data and then the right application that can analyze it and provide the right corrective outputs for your site techs and the operation of the systems.
Great. All right. Well, we're halfway through the session, so I thought I might turn to the audience and see if there's sort of some specific questions and where we want to take some of the of this panel on a conversation. If not, I'm happy to keep asking them, but just thought I'd stop and see if anyone wanted to ask any more. Looks like everyone's okay. It's interesting you mentioned in my past, I was the CEO of a qualitative research company, and what we found was people don't have, what we would say is people don't have a data problem, they have a research problem, right? Because they would take all this data, but they wouldn't know the question. And we've had the AI conversations in previous panels around ChatGPT, and that's one of the problems that most humans have is to actually ask the right question to get the right answer. So, like, is like getting the data from every sensor and bringing it all in and getting this data lake, I mean, is it, and then of course you've mentioned the compute costs of actually getting all this data together and then asking it a question, how much that costs, but let's leave that on the side. But, you know, at a high level, is it worth it? And what else do you have to kind of consider if you're gonna take this approach like they have? What are the other things that, you know, because it sounds like it's a holy grail, and I've had a lot of background in this where, you know, people put everything into this lake, and then everyone wants access to it because they think that they can mine it, and then they actually only ask about 10% of the questions of all of the data in there because they just don't know how to frame, and they have to now think about asking. It's like the way a digital native child asks about the world now with ChatGPT than someone like us that grew up in a different way, right? It's a whole way of thinking. So I guess let's have that conversation. Like, what else do you have to consider? Because it's not just the holy grail. It's also all the, as you said, the steps that are where we are and how we're going to get there. And then as an organization or yourself, how you have to change the way you think. Open. Rick, you don't have to go first. You're making notes.
What question? I am writing notes.
Yeah.
So asking the right question. So it's been really hard to get answers. So people have been kind of limited on what kind of question could I even ask. And so people's imaginations are kind of limited by what they feel they could even get an answer to. And so we're trying to give context. It's another one of the things we've done with C4SB is to create a context of, okay, so what questions should you be asking about your buildings? What questions do you wish you could answer about the efficiency or the effectiveness of your building? And because we're going to show paths to actually be able to answer the question. But in the past, it was like, okay, am I spending the right amount on maintenance? I don't know. How would I find out? Am I spending the right amount on energy? I don't know. How would I find out? So energy, operations, capital, maintenance, those are, you know, key areas, and we're creating this context for people to start putting their building into a total cost of ownership or total cost of operations framework, so people can start to say, how do I compare to my neighbor? How do I compare to last year? What should I predict for next year or tomorrow or 5 minutes from now? So having a context for what questions you should be asking about your building or your fleet of buildings, because now it matters. People are looking for efficiency, like the GSA and like Los Angeles Area Community College. People are being able to articulate, I know I'm not running my buildings well. Can you please help answer where I should focus the next dollar or the next bit? Digital solutions, cool, are the answer, by the way, to be able to answer, to be able to get questions. And everybody wants to use software to answer their questions now. So whether it's ChatGPT or some reporting tools or whatever, they want to be able to visualize and see, and then now I have another question. But we're starting with this context of the TCO or TXO framework for this is probably how bad how your building is running, which is probably badly, and give them a way to be able to identify what the different metrics and KPIs should be, and then a digital solution for actually being able to bring the technologies together to give them the help to get the answers and push buttons to make things happen differently. That was my answer.
Okay. And anyone else add, disagree?
Yeah, you know, I think the raw data acquisition that you mentioned has certainly gotten to a cost point where I think it should almost be the default in most buildings. You know, essentially infinite trend data from all your sensors, right? Like if you think about the cost, you go to Best Buy and buy it, I just bought some hard drives, 12 terabyte hard drive for $90, you know? Maybe it takes a while to read it all back, but certainly it should be a lot cheaper. And you know, with the cloud providers, you do have to watch out on cost. But it also the other point is, I think at the end of the day, people are like, oh, I have 1 billion data points from my building, and you're like, well, because it's not. So it's $2 a month, right?
Yeah.
You know,
Well,
for managed storage.
Yeah, it's the compute cost, right?
So,
It's not the storage, right?
Yeah, so you know, making that accessible for future analytics, I think what's key is to sort of stage your data investments at the time when you have a business case and money to invest, right? Like you can't go back and create the trends that were never collected, but you absolutely can go back and extract the structure from that data at a future point once you've identified the right question to ask. And so I think that you have to think about tying those investments to the questions and only performing more expensive analyses like building an ontology or restructuring the data or performing complicated analytics once you know what you're looking for. So otherwise you're unlikely to get the value out of that.
Right. Corey, anything?
Yeah, I think just to add to what Stephen was saying, like there's like a famous quote from Gregory Bateson, is like, information is the difference that makes the difference. And so if you know what you're looking for, the question is, then you can actually keep the data pretty tight. Like the fact that the zone temp went from 70 to 72, is that a difference that you care about? Maybe not. The fact that the cooling set point was 65 and it went from 70 to 72, that's something you care about because it's clearly not performing. So like, if you know that, you can log it and answer that specific question. If you don't, then you got to go with the raw data. You don't know the difference that makes the difference. So you really, unless you're going to plan all of your use cases now, it makes sense to put all the raw data in. I think for cloud, you do need to be careful, like be really clear on what you need in hot storage, the questions you need to answer right now, and then the rest can go into cold and be really cheap and affordable. But if you try and keep it all in like a hot, all accessible all the time, it does add up eventually. So my one recommendation.
I'd say certain verticals are going to demand a tighter data interval than others. And of course, if I'm in the healthcare industry or if I'm running a data center, yeah, those 1 minute intervals are essential to, again, the continuity of my operations. And I'm basically able to ensure that I'm operating as expected when I'm able to do an analysis of data out at 1 second intervals. Now, if you are a portfolio or rather you're a building owner, let's say you got a portfolio of Class B facilities, you are just going to want to flip that thing in about 10 years anyways. And we see a lot of REITs that, otherwise have a pretty massive portfolio of buildings. And does it matter to them to trend their return and supply air temperatures at 1 minute intervals? Nope, it does not. Now, of course, recording or rather collecting meter data, that's going to be essential because some of them will participate in, let's say they're getting some rebate from a utility, or perhaps they're participating in an incentive program from a state. And through that effort, you're going to need to ensure that you've got quality data captures from those meters. But even that 15-minute intervals should suffice. Now, if I'm pushing that all to the cloud and I'm that same building owner of multiple Class B facilities, again, I'm not going to invest in that. I mean, we have a difficult enough time, at least just anecdotally, getting ceiling tiles replaced in Class B buildings. These folks are operating on a shoestring budget. And so the willingness to buy kind of these cloud-based solutions aren't really as present within certain verticals of the built environment as they are within others. Now, of course, as I mentioned, data centers, hospitals, things like that, those are very critical environments. And I do believe that you're always going to need as much data as you possibly can. And so I think given the risk that are present in the event that something occurs which jeopardizes the operation of the facility, it justifies the investment into the cloud. But for some other, perhaps building owners across different segments, it's just not a CapEx expense or even an OpEx expense at that point that they're willing to maintain. And so you have to be, your data strategy, of course, has to be aligned with your organization's goals. So, again, data centers, healthcare environments, commercial office buildings, residential, they're all going to have a varying set of objectives that they're seeking to accomplish. But of course, energy reduction is one of those very important things because, well, That's less I have to pay month over month for the electricity or the natural gas or whatever it might be. But still, even with that, those are things I can capture with 15-minute intervals. And so I think there's ways to be able to compensate for some of the hosting costs, but I do believe that the data we're capturing right now and that we have been capturing for years is essential for paving the foundation for this world whereby we can actually see, okay, when I change my discharge air temperature set point by 5 degrees, what happens to all the actual VAVs, for example? What happens to the space temperature? Seeing these types of insights, I think it's going to only improve the operation of buildings going forward. And as we seek to have, let's say, some data set that an algorithm can run, a machine learning, something like that, just to use the buzz phrase, to drive corrective outputs, it's essential that we have this data now. And so we do believe in the importance of it. We do think that you should be collecting it and you should be pushing it to the cloud if it makes sense. But of course, it's all in what you need to accomplish as an organization.
Great. Scott, do you want to use one of those mics just to ask your question? Sure. That makes it easy just to turn around.
So I'm confused. So So a cloud essentially is a web server. Is that a fair statement? They're all kind of webs. I mean, they have to have a web server as a component, right? Is that fair to say?
I mean, they could just have an API service.
I was going to say,
It could be. So,
data store.
so here's my, and thank you for clarifying that for everybody. So here's my question. So I'm selling controllers, I'm selling sensors, I'm selling all that, and they all have APIs.
Yep.
They all have web servers. So how do we look at like these, I don't know, what do you call them, a cloud within a cloud? Or, so how do we like as the industry, like, where do they fall? Like, you guys are talking about aggregating data on a cloud, which is great. And yes, it's important. But what about all the other instances of cloud that we're dealing with as an industry? Could you guys speak to that a little?
It is a good question, because you go talk to Belimo and you talk to JCI Cloud, not the Cloud Chillers guy, not the the OpenBlue guy, and all these device managers, Armstrong heat pumps. They've all got essentially their own devices which integrate into first-party clouds, which just does that one piece of equipment. And I think honestly it's because the distribution channels in this industry work, like that's the thing that works, right? Because like they can still make a heat pump, put it into the channels, it comes out in a building 6 months later, and that the guy that installs it doesn't care about the cloud, but then later on the owner can, find the sticker and say like, oh, look, this thing has a web page and I can go download that. And so what you kind of end up with, I think, ultimately is like a bunch of parallel clouds, and with each of which are sort of like pointed at their own specific piece of hardware, essentially. And I think it's a bit of an open question whether or not there then becomes an overlay that essentially does cloud-to-cloud integrations. I mean, that's certainly easier in many ways, and that then gets deployed essentially post-building delivery, because I don't really see the delivery process, like you said, the people installing this stuff don't really want a cloud, they just want it to be installed. And so, that may be the way that things go, at least for a while, rather than having sort of like integrated building solutions, right from the get-go, because I think the people who have bid on, done integrated building controls, it hasn't exactly taken the industry by storm. People still buy by vertical.
Can the second Steve jump in?
Absolutely.
Thank you. So one thing that I think is interesting, and I've shared this with a few people in the past, is within the building automation industry, we started out with pneumatics, and then we moved pneumatic over electric, and then DDC, and kind of in coincidence with this, there was multiple proprietary building automation systems that were in place. Now, you heard multiple building owners at that time say, hey, we need open standards. And so, of course, you have LAN, you've got Modbus, and then I think near and dear to, of course, this organization's heart is BACnet. And some of the real challenges that they were solving when we came out with these open communication protocols is that there were all these just disparate protocols in place that was otherwise creating barriers to interoperability. And those were causing real operational challenges for building owners, and they still do today. I fear that with the proliferation of the cloud and the whole, I'm going to say the clause in from some of the folks on the IT side within the building automation space that says, you must use my API, you have to use my API. Every manufacturer is going to end up with a different API. And we experienced this before. We lived and breathed the pain. And it feels like as an industry, because, again, the cloud folks, I feel like they're shoving shit down our throat. I really do. I really do. And I'm going to come out and say it because for certain aspects, there are certain things that have been gained as an industry through the embrace of open communication protocols. And while we still believe that, of course, you're going to have certain, web services, for example, I don't want to communicate BACnet over IP across the internet. We know that, right? Because that's all encrypted. But BACnet Secure Connect has provided a great option for us to solve that problem. Now, of course, other web services, APIs are the way you want to interact with them. All right, and we get that. But when we have sensors that are coming in the building, again, I got to have an API for my IAQ sensor. I have to have an API for my occupancy sensor. You're forgetting the reason why we created these open communication protocols, with BACnet being one of the most important ones. And so I really want to, while I believe that we have to create this interconnected environment that is certainly going to include the cloud, let's remember where we came from. Let's remember the problems that we solved in the decades before us that has brought us to this point where we're almost at the moment where we can really achieve this true interoperability at scale.
And I do think there is a problem with the cloudification of a lot of the hardware, where you end up with hundreds of little clouds, and it's because so many of the hardware manufacturers, it's getting commoditized. They're trying to figure out how to actually generate ARR instead of single sale revenue, and so they're adding a cloud service. And so you can't just buy a sensor anymore. You got to buy a sensor service, and great, now your stuff's going to the cloud. It's actually a little easier to integrate, but you're paying rent on all of those things. And that is one strategy. It is one way to kind of move quickly, is get everything that's got a cloud to it, everything's up there, then you're just doing cloud-to-cloud integrations, but it could have a longer-term cost. And then the other is, getting with hardware that doesn't have a reliance on the cloud. You're forced to build the integration or work with a service that can handle that and move it to your cloud, but it's definitely a decision to be made early on. Otherwise, you end up with 100 little clouds that you're integrating with, and actually the egress and ingress on cloud services is not cheap. It's sometimes worse than storage. So,
and I do fully agree with others, Stephen, on how great BACnet is and all of that. However, if I may, I did name the company Normal Software because building in this BS industry does kind of have a legacy of weird stuff and reinventing computer science for buildings a bit unnecessarily. And I think BACnet, while it provides a lot of openness, if you show it to an IT guy, they don't like it. Let's just be honest. It's not the right answer to show an IT guy. And Secure Connect it's a Band-Aid. It doesn't really fix anything, right? It's difficult for device manufacturers to implement. You get a new, JavaScript developer out of school and tell them to do BACnet, and, they look like you're green. So I do think there's some issues there that will get in its own way, basically, even though the architecture is probably more comforting. The reality of the technology is just, it's the same as it was in '94, and so it's been a while.
Where to start? I'm sorry, Scott.
I was going to say, you agree and
Scott's
disagree with
confused.
everything.
So there's sort of new definitions of how cloud, we've talked a little bit about it, but cloud is still just not understood, first of all. One of the things as the Linux Foundation comes into the buildings world, we're going to be talking about, this kind of new definition, standardizations of how technologies can be used, leveraging things that are happening in other industries where other industries don't have any harder or worse problems to solve in terms of normalization of protocols, for instance. But some of these other industries are a little bit further ahead in leveraging some of the new architectures of cloud technologies. And again, it started off by talking about the Linux Foundation. Cloud is actually with a capital C, not a little c. So CNCF helps, it's Cloud Native Computing Foundation actually helps define the different tools that can help create these new architectures that we haven't been very specific about talking about right today. But that's one thing. Clouds are well, one of us, somebody said it. Somebody smart said it. It must not have been me. The clouds are now a new philosophy of software development. A cloud can be in the basement, it can be in the car, it can be in the cloud. The way that you write and create software and the way you innovate now is just different. So we're going to be showing different models of how that works. Again, with what we're doing with the IBB, for instance, we're showing that there's a new way to sort of standardize, sometimes we call it just standardizing the way APIs work. Saying instead of every API being bespoke and one-off, it's like, let's start to normalize how that would work and use real IT tech to do that. But the other thing is this industry is going to become more software defined and as we move forward because people are expecting it to be. Every industry is now software defined. Every industry wants to be a technology industry. Whether you're baking bread or making cars or whatever, you want to consider yourself a technology company. And so the standardization and the implementation of newer tech is going to happen. And there's really good models for it. And as companies want to evolve their tech to be more modern, use more modern, they're going to look, we want to, as the Linux Foundation, we want to show, hey, here's a model for how to do that. And sometimes we'll be borrowing from other industries to do it. But the world is moving to where everything is software. We're defined by the software we use, which is kind of interesting. We're defined by LinkedIn, or we're defined, in my case, by Bumble. But some of you got that. But as industries, everybody's becoming more software defined, and that's one of the Linux Foundation principles. Is that as people want to become more digital and they want to become more software defined, we want to show that there's models to do that.
We've got about 8 minutes left, so I want to kind of pivot away from this conversation, which I think has been useful, and just look into the future. So hopefully we're all going to be in Las Vegas in a year, or even further. But I guess what are the future and potential developments of the cloud, or the things that are coming on the horizon that you each are kind of excited about that you think this audience would find interesting? Maybe start with Holakey, sorry.
All right. So I do believe in the importance of incorporating language models into your product, whether that be a small language model or a large language model. There are certainly efficiency gains that we can all realize. So one thing that we at least believe is that reducing the time to find information or complete a task is something that really does hit your bottom line at the end of the day if you're a business owner. And so I really believe that there are significant efficiency gains that we can all realize. Now, I am excited by the prospect of being able to have a world where perhaps if we don't have somebody to come into a role, let's say have an open role, that I can actually, to counteract that, I can automate some of the functions that human being used to do. Now, this isn't because necessarily we're stealing a job. It's rather because there are no people coming into the industry. And so it's almost created an opportunity, I believe, for us to kind of counteract that trend that we're seeing. But then also for the newcomers that choose that they do want to come into the space, kind of giving them the guidance that they need to deliver a consistent and performant solution for their end customer. And so I think in light of the labor shortages and some of perhaps the skilled labor gaps that we're seeing, I think through the use of AI and of course the importance of having access to data, I think we are going to achieve an outcome whereby we can actually create this, or rather cross the divide between what is otherwise modeled and created by the engineers, of record, the design folks, and how the building actually runs. And so one of the things that, at least from a Tritium perspective, that we believe in is, I think Stephen mentioned, 231P, for example, the control descriptor language is something that, of course, they're all going to be Guideline 36 compliant. And being able to serve that information into your system integrators or down your channel to ensure a consistent deployment of the actual sequence, and of course everything would be named appropriately, you'd have the right metadata in place. But I think we're starting to see this world emerge whereby we can have a standardized way in which we deploy a building automation system. Now, when we have that, and of course we've got the data that we can access, presumably that's going to be in the cloud, then I think we can achieve these outcomes where we are saying, yeah, you know what, I have a increased confidence that if we want to reduce our energy consumption by 10%, save as many tons of carbon as we desire, we can do this because we can model it. And instead of the model, which is traditionally done at the outset of the construction process and gets thrown out the door, you can maintain this thing through its lifespan. You can actually model scenarios that are weather normalized to really say, hey, can I really achieve these outcomes? Can I truly achieve these energy reduction targets? And so we're at this precipice where we can do this as an industry. And just think of the savings that our building owners will be able to realize. If you are an SI contractor, you're going to have that much more reliable instance on the back end because you've got the guided approach. You've got essentially the know-how baked into just the way you do business. And so if we're going to continue to see skilled labor shortages, I think this is an opportunity that we all can realize.
Great. Corey?
Sure. I think I'm hoping that as things move to the cloud, we'll see the same transformation that happened in IT and a move towards standards. Like the aughts basically when like AWS came out. It's also when like REST APIs became a standard and were invented. XML for like standardizing communication protocols. And I think if all the building systems start to move to the cloud, the standards will follow because once it's all up there, you want everything to talk, and there's that layer of abstraction that exists that doesn't right now. So,
Great. Steve?
Yeah, I think the ongoing trends of containerization and connectivity are going to. I think that'll really take off, and I think that BIS is the future. I think there is a good chance we see this sort of containerized supervisor, dumb field device, smart cloud architecture really start to pick up steam because it makes a lot of sense for a lot of people.
Rick?
So yeah, so containerization that's actually a thing. Everybody knows that, right? It's like it's an architecture thing for software, right?
Yeah.
Put the code in the box.
So the expectations are just going to keep rising of more digital transformation. The executives are going to demand it. The users are demanding it. Like I said, we're software defined. We all are expecting more ability to make better decisions and be more informed. So the expectation of cybersecurity, AI, all the things we've talked about are just going to keep going through the roof. And so we've got a labor shortage. So getting more efficient with how we design systems and how we implement them, that's going to be one of the key things we have to face. But the expectations of owners of us getting our digital act together is certain that the time is here or past of being able to give better answers to how we're going to help them make better decisions for their buildings.
And I think, we had Troy from Passive Logic talking about his experience with the automotive industry, and I think it's a really good example of one that has a very different approach than obviously building. I remember in my career in the early 2000s, I was putting in telematics into cars, and we had to work in at what point you put them in the production cycle, and inevitably the more that you put them, earlier that you put them in the production cycle, the less flexible they were because you needed 16 weeks if somebody wanted to do something to have a different service because we couldn't have that software ability. But the biggest concern that the people had at the time, the car manufacturers, was the blue screen of death. Because, at that time in Microsoft, if you had a computer and it froze on you, you'd get the blue screen of death. And people were like, you can't have a car that you're driving and there's a blue screen of death, right? So, there are, now look at a Tesla, right? Like no one's going, where's the blue screen of death, right? So I do think that you're right, that we're getting to a level where we, we're at a precipice, or some of the language you guys have used about like the decisions we're making now, where we're going to go, are hopeful and has good outcomes, but, other people have been here before as well. And I think, the standards, the way that we're going to navigate it, maybe not going back to the history of where we've come from, but looking at the history and the learnings from others, whether it's, Linux or Niagara or others. So thank you, everyone, for your attendance. Thank you very much to the group of great presenters. You can continue to follow this conversation on automatedbuildings.com. We do not just do AHR. We're up in 24 hours 7 in the cloud, so you can access us there. Just want to highlight our Next session at 4 is going to be a sellout. It's the controller showdown. I think I've got the separate. So we have the best and the brightest of the control industry coming in to pitch to you to vote on which one of them is going to be the controller. I think this is the second one. We did one previously. So that's in half an hour. So go grab a coffee and hope to see you guys back. Thanks.